So these notes are primarily for fourth period since we got interrupted, but there also work as a refresher for second period or anybody who missed class today. So these are the notes that I handed out along with the 3.5 homework in your lab. So you can use this to fill out your notes or double check that you wrote the correct thing. So I'm going to go through all the notes in the first practice problem, which is what I did in the other class. Okay, so empirical formulas. Our definition, this is the formula of a compound reduced down to simplified form. All right, so that means the subscripts have been taken down as low as they can. So if we do that, if you look at these 4 examples, some of these can be reduced down and some of these cannot. So if I look, I see SO3 and this S doesn't have a subscript. That's an understood 1. So a 1 and a 3 is as simple as it can be. So the empirical formula for SO3 is SO3. But on the next one, I look at C6H12. Well, I can divide both of those by the number 6. And if I divide both of those subscripts by the number 6, it reduces down to CH2. So that's the empirical formula there. For the next one, C3H8. Well, that's an odd number and an even number. And there is no way that those can reduce down anymore. So the empirical formula there is the same as the molecular formula. And on the last one, the C4H12, both of those numbers are divisible by 4, and so that reduces down to CH3. So that's kind of how you take a molecular formula and reduce it down to empirical formula. Now that's not what we typically do. What we typically have to do is figure out what the empirical formula is from lab data. So this is kind of what I went over with the empirical formula packet, but I have most of those, so you can't really get started on stuff since I have it. So the first step is that you're going to start with the grams in the problem. And you will see that some problems give you grams, others give you percentages. So if you have percent, you just need to turn it into grams. And what I mean by that is literally scratch out the percent sign and write a G. So 50% becomes 50 grams. 74.6% becomes 74.6 grams. Done. Next, you will turn that gram amount into moles using the individual atomic masses. So you have to do that for as many elements as you have in the problem. So whether it's 2 or 3 or 4, that's typically the most you would ever have to do. So convert each one of those individual amounts into moles with the atomic masses. So you are going to divide all of those numbers that you're going to get in part 2 by the smallest amount of moles. So you are looking for whole numbers. That's what we want. And again, when I did these in class, I said it is helpful if you don't round to sig figs for these because it's the middle of the problem. You're going to get a better chance of getting whole numbers if you leave 4 or 5 decimals as you're doing these. So you're going to write these whole numbers as my subscripts. And just make sure you write the correct whole number with the correct element so that the subscripts are matching. And most problems, we are done there. But if at the end of step 3 and 4, you have some decimal numbers, well, then you can't write decimals as subscripts. So if you have a number that ends in something 0.5, you're going to multiply it by 2. If you have something that ends in 0.25, you're going to multiply it by 4. If you have something that ends in 0.33 or something 0.67, you're going to multiply those by 3. And you just have to remember to multiply everything. If you have to multiply, you multiply everything. Okay, so that's the most common type of problem, just getting empirical formulas. Sometimes you can be asked to then calculate the molecular formula, and the thing you need here is you must have the molar mass of the molecular compound. And they will tell you that piece of information. It will be in the problem. Okay, so you've got 3 steps here. Step 1 is to calculate the molar mass of the empirical formula. So either because you've found the empirical formula in a previous step, or they've given you the empirical formula. Regardless, you calculate the molar mass of the empirical formula. Then you are going to do a division step. You're going to take the molar mass of the molecular compound, so the molecular molar mass, which should be a larger number. You're going to divide it by the empirical molar mass. And you're going to get some number. And it's going to be a whole number. And then the last step is whatever that whole number is, that tells you how many empirical formulas fit into the molecular formula. So you're going to multiply the empirical formula, subscripts, by that whole number. And I did one of those in class. Okay, so let's do this first example here in the problem. All right, so it says a compound containing nitrogen and oxygen is decomposed in a laboratory, found to contain 24.5 grams of nitrogen, 70.0 grams of oxygen. Determine the empirical formula. So I have 2 elements, so I'm going to write them on top of each other. I have 24.5 grams of nitrogen, and I have 70.0 grams of oxygen. So the only thing we can do with grams is turn it to moles. So I need the atomic mass of nitrogen, which is 14.01. Since I start with grams, I have to divide by grams, which is the atomic mass, 1 mole on top. If I do that in a calculator, 74875. So like I said, try and write 4 or 5 decimal places here because it's going to give us better rounding later on. So 70.0 grams of oxygen. Well, the atomic mass of oxygen is 16.00. 1 mole there. If I divide those 2, I get 4.375, and that's all that's in my calculator. So the next step is divide by the smallest mole. So which number is smaller? Well, clearly 1.74875 is smaller. So I'm going to divide both numbers by that number. And that is going to give me 1, obviously there. And this is going to give me 2.5. So I can't have a subscript of 2.5. So this applies that step 5 up above where we have to multiply. So if I end in 0.5, I multiply both of these by 2. So that top number becomes a 2, this bottom number becomes a 5, and I write those numbers as my subscripts in 2O5, which is dinitrogen pentoxide. That's as much as I did in the other class, so now everybody can be in the same spot. Go ahead and try the pre-lab so you are ready to go for the lab in the morning.